Hi, everybody. This is Gigi from Kauai Community College. In this video, we will be talking about applications of right triangle trigonometry. All right, so right triangle trigonometry. Here's a problem for you. Walking to the hotel. So on vacation, I stayed at a hotel that's next to a shopping mall. After shopping for hours, I have to carry tons of shopping bags back to the hotel, but I have to walk up an uphill walkway, a little bridge from the mall to the hotel. And that bridge has a 20% grade. Okay, yep, I was feeling pretty bad about walking up, even though it's a short distance. Now, if that is the information that's given to you, can you find the angle of inclination or angle of elevation? Okay, so pause and draw a picture. All right, so once you come back, does your picture look something like this? Okay, now let's see what it means to have a 20% grade. Okay, a 20% grade is a slope of 20 over 100. So that's 20 right here over 100. It's like the slope of the line there. Okay, now we're looking for this angle right here, angle theta. Okay, so we have in a right triangle, this is a right triangle right here with the right angle being right here. And we know the length of the opposite and the length of the adjacent side. Opposite over adjacent, that calls for tangent. So tangent of theta is 20 over 100 or 0.2, that 20% grade. Now, to solve for theta, we have to undo tangent. And so we find that inverse tangent button. And so theta is inverse tangent of 0.2, which is approximately 11.31 degrees. So this angle right here is roughly 11.31 degrees. Okay, that's pretty straightforward, right? Word problems could be really scary, but once you draw out the picture and you apply the concept and you think about it, it's not too bad. Okay, next, the airplane problem. Okay, so the controller is told by a pilot that she wants to land. She is currently 40,000 feet, at 40,000 feet, and wants to know what angle of descent to take. Now, the air traffic controller can see on the on his radar that the plane is 100,000 feet away from the runway. Okay, so note that the radar only read the direct measure from the plane and back. So when you draw that picture, the 100,000 is your hypotenuse. Okay, so pause and start thinking about the picture and which trigonometric function you need to apply. Okay, so does your picture look something like that? Okay, so we are looking for this angle right here. Okay. And we have this being 40,000, and that's opposite, and this being 100,000, and that's the hypotenuse. Opposite over hypotenuse, that calls for sine. So sine of theta is 40,000 over 100,000, reduced to be 2/5. So then theta is to undo sine, just like how we had tangent, inverse tangent undoes tangent, inverse sine will undo sine. And punch that into your calculator, you would get approximately 23.58 degrees. Okay, so another very straightforward, it's a matter of understanding the problem, drawing a picture, and just think about the concept and which trig functions you're going to use. Okay, now the next example is going to be a little bit more complicated, but still going to just apply your trig functions because that's all that is being used for this unit. Okay. So while hiking up Kokei with two friends, the two friends are standing 100 feet apart. Okay, so visualize that. Two friends 100 feet apart. They both look up and saw a beautiful EEV on an ohia tree between them. So a tree is in between them. Okay, and the angle of elevation from the two friends to the bird are 20 and 45 degrees, respectively. How high up the tree is the EEV bird? Okay, so pause and draw the picture. Okay, does your picture look something like that? Two friends, bird on a tree, and we are looking for Y, meaning how tall, how high up the tree the bird is. Okay, now let's define some variable. We know that the length here on the bottom, the red length from one friend to the other is 100, right? So if that's 100, I will define this to be X right here. This part is X. And if that part is X, then the second part would be 100 minus X right here, okay? Then what we're going to do is we're going to look at the two right triangles, because in order to apply trigonometry ratios, we need to have right triangles. So do you see two right triangles there, right? In the first right triangle, the one on the left, you have the angle 20 right here, opposite over adjacent, that would be tangent. So tangent of 20 degrees is y divided by x. Multiply by x to both sides. To undo x, we have y equals to x times tangent of 20. Okay, that's the information you'll get from the left triangle. Okay, so you may need to pause this video a few times, but that's okay, right? Make sure you digest the information. Now, try on the right-hand side. Okay, looking at the angle that is 40 degrees, we have y over 100 minus x, and that would be opposite over adjacent again. So you'll have tangent of 45 degrees is equal to y over 100 minus x, right? So multiply both sides by 100 minus x, you have y equals that. Now, both of these are y, right? So we can do a little substitution here. So that means x times tangent of 20 would have to equal to the right-hand side here, right? They both need to be the same because they're both values for y, right? So y must have the same value. When we set the two right-hand side equal to each other, we have this. Now, tangent of 20 and tangent of 45 are ratios, right? Trig ratios. And ratios could be a fraction, or it could be when you divide out the fractions, you could have decimal. So punch that into your calculator. We should have 0.364 for tangent of 20, and then tangent of 45 degrees is 1. Okay, reduce that and make it nicer. Add x to both sides, and then divide by 1.364 to get x by itself. and x is approximately 73.31. Okay, so now we know that this is 73.31 right here in this triangle, right? So now how are we going to find y? We know the angle. We know the 31.31 as the adjacent side. And we are looking for the opposite. Okay, so we would write tangent of 20 degrees is equal to y, which is opposite divided by adjacent, and that's the 31.31. Okay, then you multiply by 73.31 to both sides. Y is 73.31 times tangent of 20. Plug that into your calculator. Y is 26.68 feet. So the EV bird is roughly 26.68, or you can say roughly 27 feet up on a tree. Okay, that is probably one of the more complicated ones that you have to deal with in this class. And that is it for today.